For AMC 8, question 21. 21 to 25 are the hardest 5 questions for AMC 8. So those questions get a lot more difficult. But again, for each question, we can figure out what's the key things you can learn from each question. So let's take a look. A group of frogs called an army is living in a tree. A frog turns green when in the shade and turns yellow when in the sun. Very, very special frogs. Initially, the ratio of green to yellow frogs was 3 to 1. Then 3 frogs moved to the sunny side and 5 yellow frogs moved to the shady side. Remember, they will change color. So 3 green changed to yellow and 5 yellow changed to green. Okay. Now the ratio becomes 4 to 1. The question now is, what is the difference between the number of green frogs and the number of yellow frogs now? This is for the 4 to 1 case. Now, not originally. So be careful. So this is a wording question. Not a geometry, not 3D geometry. It's a wording question. And it will involve system of equations. But we'll go through this step by step. For a wording question, the first thing you need to do is to translate every sentence into an equation or a number or something mathematically easier to express. So I call this a translation step. And we do this sentence by sentence. A group of frogs is living in a tree. A frog turns green when in the shade and turns yellow when in the sun. There's nothing really mathematical we need to translate, so we can keep going. Initially, the ratio of green to yellow frogs was 3 to 1. That's something you can express in math. Green to yellow is equal to 3 to 1. For every yellow, there are 3 greens. Or what I can see is G, the initial number of green, is equal to 3 times Y, initial number of yellow. I'd better write my Y more clear like this. That's a equation. G equal to 3Y. Green is 3 times yellow. Alright, now the second part, or the next sentence, is a key. 3 green frogs moved to the sunny side, and 5 yellow frogs moved to the shady side. So 3 green becomes yellow, but 5 yellow becomes green. To do a translation, in the end, what is a change? Did we get more yellow or less yellow? Well, you get 3 more new yellows, but you lose 5 previous yellow ones. So yellow decrease by 2. And green increases by 2. That's a key for you to translate this sentence into a math equation. So you're getting y minus 2 as a new number of yellow. Again, I should write y in a way that would not be misinterpreted as a g. So y becomes y minus 2. And g increase by 2. So g becomes g plus 2. And now the ratio is 4 to 1, which means, so this equation or this sentence now needs to be translated into g plus 2 equal to 4 times y minus 2. And that is our system of equations. Put them together. G equal to 3y. That's our equation 1. And then you translate this sentence, and now the ratio is 4 to 1. You get the second equation. Two variables, g and y, two equations. You are good to solve for it. How do we solve a system of equations? System of equations. A key to solve system of equations is try to cancel some variable. Your goal is to turn a system of two equations, two variables, into the equation for one variable. Then you can solve for it. Well, in this case, g equal to 3y. So you can express g using y. That's how you cancel variables. Because now, by using 1, g is 3y, you can replace the g here by 3y. Equation 2. And then you will get 3y plus 2 equal to 4y minus 8. Again, one more time, if you're new to system of equations, what you will see me doing here is I'm trying to remove one variable. So I only have one variable left, and I can solve for it. So in this one is easier. 3y plus 2 equal to 4y minus 8. Y is equal to 10. And yeah, I should write this way. And then g is equal to 30. So initially I have 30 green frogs and 10 yellow frogs. But remember, they are looking for the difference between green and the yellow now. Now I have g plus 2 equal to 32 green frogs. Y minus 2 equal to 8 yellow frogs. And double check the ratio, 4 to 1, that works. And their difference is 32 minus 8 equal to 24. So the answer is 24.